This retirement portfolio problem is one that we have covered in the earlier section of this course. Basically, here's the setup. Jack and Mary, this couple, are planning to retire in 20 years. They plan to invest in a mutual fund that has an expected 5% annual rate. Each month they put in $1,200 at the beginning of each month, and they would like to start with $5,000. So the question is how much their investment will be worth when they retire in 20 years. We use this example to illustrate how to use future value VF function. Here the first argument, which is the annual rate of return, is fixed. A natural question to ask is, what if the return is fluctuating? That's exactly what this next problem is about. Here we assume the return of this mutual fund is random and can be modeled by a triangular distribution. The worst case is -2%, the best case is 12%, and the most likely case is 5%. Now, according to the definition of triangular distribution, the mean is 5%, according to the formula here, and the standard deviation, we can work out through this formula, is about 2.86%. Okay, how to run the simulation using VF, the future value function. We have talked about how to generate values from this a triangular distribution, and we just copy the steps here. So we use rand function a CDF, i.e. a number from 0, 1 randomly, and this column C and column D are basically used to back out the X value from the CDF. The details are in that example. Now, having drawn a random value of X from the distribution, from the triangular distribution, we just plug in the future value function. So here's the formula, and we run this many times. To be precise, 10,000 times here, and with those 10,000 simulation rounds, we then go back and take the average of the portfolio value and the standard deviation. Now, it turns out that the value is about $543,000, and compared to the deterministic value, it's a little bit more. However, if you notice, it has a pretty large spread. In fact, we could use pivot table to draw the distribution chart, and here is the results. Well, a couple of interesting things can be extracted from this chart. First of all, it has a pretty large spread, as we just talked about, and it has a single peak, but it is not symmetric, meaning that it has a large long tail to the right. Okay, and we could in fact check whether we got the right rate, and here's just using pivot table to draw the distribution chart for the triangular, and it seems to be correct.